let's go ahead and get started here. Talking about membrane technology and mining specific innovations with Jacob Croall, who is a member of the Innovation and Commercialization Council of NREL at NAWI, wrong N, and great to have him here today. But before I introduce him, I'd like to turn it over real quickly to our moderator, Ryan, just to provide some logistical information.
Thanks, Matt. Hi, everyone. My name is Ryan Ingwerson. I'm with the National Renewable Energy Laboratory, and I will be your Zoom host for today. A few things before you get started. One, this webinar is being recorded, and we will post it on the NAWI community website as soon as possible after the event. Everyone is joined in listen-only mode. That means you will be muted throughout the duration of the presentation. If you have any questions, we encourage those, and please submit those via the chat box. We will address those audibly at the end of the presentation. And if you have any audio issues, please first try connecting through your phone. If you continue to have any issues with audio or any other technical issues, please let me know and I will assist you. And with that, I'll turn it back to Matt to introduce our speaker.
All right, Ryan, thanks a lot for getting us all, make sure we're all connected here. So first of all, it is so great to have Jacob here again. Jacob is at Newmont Mining. He is the Director of Global Water Management and Treatment. And as I mentioned, is engaged with the NAWI program through the Innovation and Commercialization Council. It's been great getting to know him and work with him. The mining community faces very interesting challenges when looking at water. And we always want to try to make sure that we understand a full perspective when we're looking at different research challenges that the hub goes after. So Jacob, again, really appreciate your time here. I always love reading your bio because surfing is in there on what you did when you were working your first time in a metallurgist at the Waihi. I'm going to say that wrong, Waihi operation. So any place where you can work, fish, and do all those things at the same time and surf is a great place in my mind. So thanks a lot and look forward to hearing from you today. Please take it away.
Thank you very much. I'm just going to share my screen here.
And I'll confirm that we can all see it here. I can see it perfectly.
How's that? The right screen?
You're good. Looks great.
Good start. Thanks for the introduction, Matt. Yes, the days of surfing and fishing as a metallurgist in New Zealand at the Waihi operation certainly seemed like a long time ago now, but it was a great place to start, and that's a great segue into introducing this topic today. As out in New Zealand, we had a really big problem with too much water, and we solved that with some membranes, and that began my journey in Newmont, which is now 17 years deep, looking at application of novel and in some cases not so novel water treatment applications and managing water across our business. So I will start today just introducing a little bit about what I'm gonna talk about. Yes, it is about membrane technology, and I have two case studies that I'll present at the end here that are focused on two different types of membrane innovations that we had to develop in Newmont. I'll also talk a lot about how we got that innovation across the line, what the drivers were, why we had to innovate, and essentially the intent is to give a bit of a playbook of how to engage with a mining company talking about innovation and talking about application or commercialization in particular, because mining is a particularly difficult space. And I know, and I've seen the industry over the last 17 years really develop. I've seen pockets of big focus and market development around mining and understanding that there's really big opportunities. There's real development potential as well. And it's been a difficult space for folks to really engage in. And so I want to give a little bit of Newmont's perspective from the mining side, and my perspective being a technical operator within a large mining company like Newmont. It doesn't specifically apply to smaller or junior mining companies. I'd say that Newmont has some specific advantages based on our scale, and I'll go over a little bit of that. But this presentation, who is it aimed at? It's aimed at, if you're looking at market development and business development, and you've got a product, or you're looking at developing products, how would you engage in the mining industry, and how would you assess the opportunity, and whether or not there's a pathway there, and how to bring that forward, and what the timelines look like. And then what would be an investment strategy for those opportunities, and how do we scale it? And then what technical support looks like. If you are a person who is highly technical, how, as a technical operator, do you engage in that process to bring these things through to market, or application, or just deployment in a lot of cases? So a little bit is also aimed at the technical development space as well. We, as a mining company, are looking at fast following and a little bit lesser development, which is ironic considering today I'm going to tell you about two things that we developed. And then again, project management, what to expect and how it looks from our side. And if you have any questions at the end of this, or just throw them in the chat as we're going, I'm sure we'll be able to progress through in a linear fashion. And I'll, if I can go back to slides, I'll jump back to them and address them specifically. So, but first, a bit of a recap. I did give a presentation about a year ago on what's driving water risk in the mining space. So I thought I'd take just a few minutes here to recap those elements and build on it for the rest of the presentation today. So we do see rapidly increasing social, political, and even now cost concerns relating to water performance. We're seeing in Newmont large escalations. We're seeing development and our operations not keeping pace with the regulatory elements. So we're seeing a lot of pressure. We're seeing in our areas that we operate, we see in-migration because of the opportunities that we present as a employer, and that cascading effect. And then we see development of water scarcity, or conversely, water surplus, and that can lead to constraints as well. There's a fantastically small operating environment where we don't have too much or too little water, and very rarely do we have an asset that will actually occupy that space. We're seeing increasingly stringent regulations as well, some that make some sense and some that maybe are a little harder to understand, but we're obviously very supportive of doing the right thing. And then we do see drivers that we look outside of our fence, where that was traditionally what we could control, but we know that we have influences beyond that fence line. And so we're starting to see regional impacts that we want to be ahead of and supportive of, and again, aligning with Newmont's strategy of improving lives and being a fantastic employer and stakeholder in communities. We want to make sure that we're cognizant of those impacts. So a big driver for this, I mean, it wouldn't be a conversation without talking about costs, but costs at closure in particular have escalated to unsustainable levels, or very challenging levels in most cases. And understanding those is something that we want a longer runway so that we react less. And reactivity is the killer. And I'm going to talk a lot about reactivity as I progress through the slides today. Following that, what do we see in industry trends? Well, we see a shifting industry, especially in precious metals mining and other commodities. Perhaps we're seeing that shift in the regulatory space, but in our space, we're seeing a macro shift in the type of material, the type of ore that we process. We're seeing a shift away from oxide mineralogy into sulfidic mineralogy, sulfides in particular. And we know that those have challenges related to the scale that we operate at and the environments that we operate within, or the locations and physical geographies. So we're seeing movement into places that have more challenges around surplus or deficit of water. We're seeing the sulfidic mineralogy impacts that affect water quality. So it's quality and quantity that we see as challenges. So we need to be and execute a multidisciplinary approach. We know that it's a combination of strategic and tactical. The strategic elements that look at the long-term way that we operate, but the tactical has to be backed up in sense and in science and in engineering in most cases. And we're seeing the need for greater technical capability with much more targeted tools that can help us to predict what the mitigations and engineering constraints might be. So a piece here that I've added is around external partnerships. So we can't do it on our own as a mining company. And I'll talk a little bit about our strategy around what that external piece looks like and how we've come to develop some of the technologies that we've developed. This slide is an ugly slide, but I wanted to leave it here so people could see this because I'm going to refer to it a couple of times. These are our focus areas as a mining company. You'll hear a little bit about acid rock drainage. Acid rock drainage is something that's gone on for hundreds of years since the beginning of mining. It manifests itself in a number of places, pit lakes, for example, heap leach facilities, waste dump chemistries, and it requires treatment. So those are sort of the drivers there. And then what the specific parameters of concern that we're looking at, obviously metals and metalliferous drainage, saline drainage, those are things that we need to be controlling of. Particular elements around nitrogen, ammonia, nitrate, nitrite. These are often crop up as things that we need to solve for in our treatment strategies. Sulfates, it's been around about 10 years as a pretty big driver, and that's going to be one of the case studies that I talk about today, is how we use membranes to solve the sulfate issue. Obviously, very rarely do we see these things on their own, and so that's something I'll talk about from a strategic engagement perspective, is what is the technology that you have that you want to bring, you want to commercialize? Is it specific? If it's very, very specific, mining has a pretty wide range of challenges, and it's very rare that a very, very specific technology would be something that we would want to add. That's why membranes, as an economizer and a bit of a catch-all, are something that you would probably want to integrate into your flow sheet, because if you can treat things lower volume, higher concentrations, that's always a win for us. And making membranes work to deliver that, and I'll talk a little bit about what that economization really works towards, and that is getting more water out the door. And we know that RO membranes will usually operate around 75% recovery, and you've got to deal with that 25%. So that 25% is something that we want to target and be able to treat cheaper, faster, better, and send out the door as a combined effluent. And that's where the innovation kind of sits, and it's about targeting the right place, the right way. But membranes in particular are an enabler of that innovation. So a couple other things in there around solid liquid separation, things like that. But generally speaking, those are technologies that already exist, and we're not going to see, in my opinion, vast advances in technology around those areas. But I've listed a few other things on here. You can come back to it. I'm going to ask a couple of questions later around what are you targeting with your innovation or with your technology. Is it adaptable? Is it scalable? Is it flexible? Is it one thing in one place? And if it isn't on this list, it would be hard for us to want to look a bit further. So another couple of slides here around just cementing why are we doing this and where does it sit? But we own the liability. So from an organizational liability perspective, these liabilities can be very, very long-lived and very, very expensive. So that's why we want to look very closely at solving the issues. And we want to look at it from a number of sort of arrows in the quiver. So prevention is an ounce of prevention is worth a pound of cure. That's on my next slide. But those are the elements that are really important to us, and that's how some of our guiding principles, right, around how we look to minimize, and then if we're going to treat, what's the innovation and what does it open up for us in terms of the opportunity to both make money, but at the same time, develop the business. And here's a pretty typical cost curve that drives us, and like I spoke about at the beginning, what we see is these rapidly increasing costs at the later in mine life and in closure. And in those locations, and I'll talk a little bit about it here, we don't have the economic models in place to be able to adapt to those increasing costs. So it's just cementing that recap here that this is a significant driver for the business. There's a lot of opportunity here as well, but those targeted areas, we've got to be focused on what they are and how they affect our business. So Newmont operates an investment system a lot like other companies, but Newmont's is fundamentally different. Newmont's investment system has been in development now for about 12 years and is now, I would say, at the norming and storming nomenclature. We're at the storming side of things. So we know it's effective. We know how to refine it. Our refinements are now getting to the more targeted areas rather than big changes in the way that we execute on investments. So on the left-hand side, that's our stage gate process. We typically in the water space, we come in a couple of places, and I'll talk about how we engage in that and how we're flexible in just a second here. But the purpose of this is to make sure that we spend our shareholders' money and stakeholders' money wisely. And it is designed to make sure that those decisions are aligned with our purpose, vision, values, mission, et cetera, and obviously policies and strategies, and obviously maximize shareholder returns and have an acceptable level of risk. And that's something that is easy to say and hard to do, but that's a key element in the way that we approach these decisions. And we need to base it on a consistent framework. What you see here is essentially a summary of it, defining the case, identifying options, which is a critical element and really sets Newmont apart in the way that we engage the options assessment. We will develop options equivalently. We won't just sort of get a gut feel and go, well, that's what we're going to do. And we want to make sure that those consistencies, the consistency around those decision-making processes is really applied at that option assessment phase. Then we get into recommendation, refining, and making sure that we're confident, and then execute and operate. So that investment system is something that when we engage, and I'm going to refer back to it in a couple of slides, and the meat of this is I'm about to show you how to engage, but using this as a framework of where we engage in that process. So when we bring innovation in, we've got to have a driving force, and we've got to have a start point. That start point is in a couple of places. I see there are 3 entry points. The 3 entry points are greenfields, brownfields, and oh no, I've got some trouble. So the greenfields one here is where we have most flexibility. We can bring a technology in as long as we know what we need, but we also have that's the least amount of data available in a greenfields situation. Now, greenfields is a mining term, and I apologize if it's unfamiliar, but essentially it means blank slate, new asset, never been developed. We're starting, we're going to move forward here. So we can bring in technology at that stage into our economic models relatively easily. We don't have expectations around what the IRR will be, so investment rate of return, and some of those other more business-oriented elements of project development. So we can bring them in and we can say these are enabling factors. Now, we've got to make predictions. So we have a dichotomous situation where that's where we have the most flexibility, but we have the least certainty. So we've got to be able to align slightly differently and have an innovation strategy that parallels our investment strategy. So our innovation strategy has got to be well enough developed that we can bring in technology that we expect or reasonably expect in the future may be something that is advantageous to us. So the two things, you've got to be aware of where are you coming into this process. Are you coming in on the investment side of things, in which case we've got to have a business case, or are we coming in on the innovation, which we hope will develop into a business case when the need arises, and we've got reasonable certainty of what that expected need would be. So in the brownfield space, we've got a lot more data because we've been operating for a little while potentially. We know what our envelope of certainty is, and then we start to see that there's a problem, and we now need to execute a solution to that problem. But we can get some sticker shock because often the economics aren't baked in. So now is where this is the highest risk, right? So as a technology provider coming in the brownfield space, that's where there's a number of off-ramps. And you might start in and we start to develop something and say, hey, yeah, we've got a technology, but we're not necessarily in the development phase. So that goes back to innovation versus execution and project development. If you've got something that you think is reasonably ready for market, there might be a place there, but we've got uncertainty around costs, uncertainty around efficacy. How well does it work? Can we rely on it? And if we've got the larger the cost, then the more certainty we require as a business. And it's fair to say that mining is pretty reluctant to make changes and take risk, especially in the technology space. So it's something to be aware of. But what I've said here is that sticker shock really leads to an avoidance strategy. I can't bring that into my model right away. And we start looking for off-ramps. So a little bit about me in this space, right? So I'm as director of water management and treatment, it's my job to make sure that we don't let ignorance or optimism creep in, and that the investment system is absolutely my best friend. And Newmont has graciously allowed me to operate in that space and be a bit of a bugbear for a lot of people, where we say, hang on, let's get this right. And we come back to those policies and the strategies and our vision, values, and mission, et cetera, et cetera. So this is where I sort of step in a little bit. Now, it's easy to develop something in the greenfield space. You've got a bit more time. You've got a lot of flexibility. In the brownfield space, it's very, very hard. So that's where we start to get and put pressure on organizational maturity and say, hey, that doesn't fit our standards. Let's make sure that we do this the right way. Now, we've got to make sure that we've got the complexity recognized. The devil is in that detail. We've got to make sure that we respect cross-functionality, because if we start to go down roads with blinkers on and really not focused on that cross-functionality, we can end up in some dead spots or just into brick walls where we go, well, we didn't know that you needed that, or that was a requirement, or that was a limitation. We've got to make sure we're doing this, that we have to be very diligent in the way that we apply this and bring this forward. And again, aligning those strategies around innovation and project execution and finding those crossover points is really, really important. And the last one here is uh-oh. Now, uh-oh is we've got a problem, probably regulatory. Maybe there's some other problem that we have that we've got to do something about. Generally there, we got a lot more flexibility to get something done, but the timeline becomes very, very short. So the costs typically go way up. And on the right-hand side here, and this is, I wish this wasn't things that I've experienced, but this is a lot of the way that we have to be aware of the organizational development phasing here. So in the greenfields, well, you can't tell me for certain that I need that, so I'm going to say I don't. That's a difficult one to argue, but we've got to be more disciplined, and with that cross-functionality and that understanding and that education is a really important point there. Again, it's where I come in the business. Then brownfields, I might be able to avoid this. I don't want to be the one to pick up that can. Somebody else didn't pick it up. I don't want to be the one to pick that up. What are my off-ramps here? How can I get off this track and minimize those costs? And then last one is, well, hang on a second, I didn't know about this. And that's a real difficult one, because often it's the messaging or the communication pathways aren't there. So that again, coming back to my function, making sure that we're consistent and persistent in the way that we approach these things. So next one here is really just taking those concepts just a little bit further. Water is not our core business. We're going to find those off ramps. We're going to find those minimizations. We're going to take time value of money and we're going to delay. Those are the ways that we have a challenge. So what I'm sort of trying to explain to folks is find your ways in and develop your expectations of where it might work. Coming in at the end, I think, is where a lot of folks saw opportunity. Wow, there's companies that have got huge problems here, and our technology can slot in some part here, and we're going to be able to hit go and get it done really quickly, and we'll make tons of money. That is the last resort for this, and is not a good way of doing business. So yes, that has happened, but I think that people came into the business when there was a lot of consolidation in the water industry, expecting that to be the way forward, but not understanding that in mining that we've got to rationalize these things and make sure that we're doing the right thing. Going back to the whole purpose of our investment system, making sure that it is the right thing to do for our shareholders. So what I've put together here is a bit of a summary around the interaction of the technologies, our SNER, which is sustainability and external relations obligations, and cost, right? So what we have here is does the technology work? Is it specific? Is it too specific? Is it scalable? Is it something that we can scale here? Is it adaptable? And what is the ultimate quality that I'm going to achieve out of that technology? SNER side of things is around legal compliance, social license, external relations, et cetera, and cost is pretty simple, right? OPEX, CAPEX, there's got to be an escalation piece in there. And then what I alluded to previously is where are you at, or where is this company at in terms of their tolerance to those costs? And the point in the middle here, the intersection of all of these is the ideal situation, but we very rarely land there. And so what happens, or what's that journey? Well, the journey is in the beginning, we might have an SNER goal, and then that leads to a technology interaction. So we go, well, where do we fit there? Well, we can find that spot, no worries. Depending on the project, cost isn't really considered at that point. But as you move forward, the technology and the costs start to be considered, and you start to value engineer, and you start to think, well, what do we really need to do? What's the minimum that we can do here? And then when we get to the certainty end of things, what typically happens is on that far end of the scale there, if you do take the off ramps and you do try to avoid and you do try and take advantage of delays, eventually SNER always wins. And that is, you've got to meet your obligations, legal or otherwise, or in our case, our internal standards. And that's where there's a significant interaction with cost. And what I've said here on the right-hand side is, at the end of the day, our obligations always win. And then cost isn't necessarily a driving force. The picture I've put here is one of the mitigation strategies that you might see in the mining industry, where we can cover the material that's causing the issues. And that can work for a significant period of time. Whether or not that is acceptable over the longer period is a different question. But those are some of the things that we might end up doing. So when we start in a project and we go, right, what's our tolerance? What's our feed water quality? Where are we at? Often we don't have that level of certainty, and you see this evolution and you see this development and then you see this escalation. And that's when we start, you've got to understand, how do we manage that in terms of the development of the technology? Again, to reiterate, multiple off-ramps. So I've put a picture of me and my team on the right-hand side here. We're the ones sort of sitting there going, what are you doing? Let's make sure that this fits and that we can make this work, because we do want to be enablers in the business. But as you saw previously, we don't want to squeeze it to the end where reaction takes hold and the cost really starts to escalate. So we're the ones that sit in the middle of this and make sure that we're diligently executing the investment system. We're also the ones helping to provide the execution elements of an innovation process. But the off-ramps are pretty clear, right? Industry macroeconomics. We got changes in gold price, precious metal prices. That can change the economics of what your whole project looks like. That can end that project or can make it substantially different. Production elements, restrictions, those elements as well. Closure. we can develop closure cost estimates and understand that that might not be something that we want to sort of tackle. And then obviously cost. And then another one here is regulatory relief. There may be elements there that site-specific water quality parameters, etc., permitting, working with our regulatory stakeholders to make sure that all of those things are taken into account. So that's a bit of a journey to how we innovate, right? Or how we bring these things into the business. And at the bottom here, that picture there, that's the facility that I work out of. So we have a very, Newmont being a larger company has a fantastic facility that we are, it's a technical facility. We're able to do some of these developments, certainly early stage development pieces in, and then we want to work with external providers or innovators or technology providers or technology partners, and we can utilize our facility. So I just wanted to a plug for that facility. It's pretty awesome. So now I'm going to talk a little bit about innovation. So we have an innovation strategy in our organization. It's value-based, people-driven, but we are fast followers. So we're not going to go out and do hard, like blue sky engineering and innovation in this. We have looked at doing that in the past, and Newmont has a reasonable track record of bringing a number of, I think we currently protect 60 or 70 patents in the technology space, not related to water specifically, some do, but around metallurgical practices and technologies. So we have a number, we've got a good track record of doing it, but we have publicly stated now that we want to be fast followers. We want to look at other industries or even within the same industry, folks that are developing technology, and we want to be looking at that ready for market type development. And we've got a process where we can bring it in. We have a system where we can value it and then decide if we want to execute early stage development or contribute to the development. So we call it new to Newmont. It doesn't have to be like blue sky or brand new stuff, but new to Newmont type stuff. And what does it bring for the organization? So from now to the end of my presentation, I'm going to talk a little bit how we use the investment system, how we use the innovation process, and how we use those wider industry observations and Newmont observations to bring something forward. So, and how we did it, and a little bit less about what it is. I can't give you all the details and open the curtain, but I can give you a fair degree of understanding of what the drivers were and what we landed on. So a good part of this, and I'll talk about at the end, is replicating things and being able to push forward and be able to say, yes, this worked really well. Now, just backing up a second, water treatment in particular and water innovations tend to be quite specific. So what we see in Newmont is a wide range of parameters, and it's very unusual that we would find something that a specific technology would come along and solve for us. So we're looking a little bit wider. We're looking at things that are adaptable, scalable, that have a bit of a wider view or a wider efficacy. So that's what we're driving towards here. So I'm going to talk a little bit. So I put some words on the slide, but I'm pretty much just going to talk about it and give you a bit of an understanding of the evolution of the challenge rather than walk you through a specific sort of process. It's a bit of a story. So we have an asset, Sub-Saharan Africa. It was a brownfields entry point for a water treatment system. We had limited data, which is unusual for a brownfields, but it just wasn't tracked, and we didn't really have good predictions around the water balance or the water quality. We knew that we had an issue around a water balance. In fact, I seem to remember people requiring snorkels and telling me that we didn't have a positive water balance. And it's that ability to cognitively distance yourself from the very obvious things around you. So we had a lot of pushback internally, and it goes back to what I was saying previously. We just accepting that those costs are going to have to come into the business when you didn't expect it can be a real cultural shift. And so we had a lot of pushback internally. And then we had some regulatory uncertainty that further bolstered what that internal opposition was. Obviously, cost pressures were challenging. We're talking 2012, 2013 wasn't a great time for the industry. We knew that there were some chemistry changes. We knew that there were some things that probably weren't going to go away. But again, going back, we couldn't say for certain exactly what it was going to be. So people said, well, it's probably going to go away. And those make for interesting meetings, I can tell you that. So, but at the same time, that's when we were developing our new strategies around SNER, ESG, and Newmont really assigning values and value to that. And so we also had a challenged regulatory environment where there were some issues around getting it through a sophisticated legislature and things like that. So we had to kind of say, well, what do we need to do and what's the right thing to do? So we took a few off-ramps. So in the development of the process here, we took a few off-ramps. We engaged consultants. Consultants didn't really have that connectivity into the business. So that's why, and that's where I come in as well, is making sure that we own these outcomes. We're accountable for this stuff, and we can then get the consultants to be more useful to us rather than them coming through and trying to solve something that we ultimately don't like the answer for, or we have the ability to ignore. So Newmont says, no, we're going to have that internal accountability for this. So that's where we developed that. We got a lot better through that process. So we didn't have that cohesive strategy at the time, accompanied with lack of data and a lack of detail. It made it very difficult to make investment decisions. And then the investment system was in its infancy and was being developed. So we started moving water around. We challenged the regulators on a couple of things. We reworked some assumptions, and in the end, the problem didn't go away. In fact, it got a lot worse, and that's where reality sort of hit us. And we had to deal with some permits. They weren't necessarily withheld, but the permits, they said, well, you're not really demonstrating that you're fixing this issue. Now, we didn't have anything that went beyond the fence, and we didn't have anything that was required fines or anything of that nature, but we were able to manage it internally. And then we became very clear that we were not going to be able to manage it for much longer. So our issues were nitrate, ammonia, and sulfate, and those regulatory limits were really strict based on a global perspective, and they were in pipe discharge locations. So we didn't have any dilution that we could account for or take credit for. So we had to produce something at the end of pipe. Now there's a number of things that occurred that really helped us to cement what those parameters were. But in the end, any sulfate restriction sub 2,000 milligrams per liter is going to require a membrane. So we looked at a range of different options. We looked at tringite precipitation, which is a calcium, it's a very strange crystal structure of a sulfate molecule. We looked at things like eutectic crystallization, freeze crystallization. We looked at evaporation technologies, and those all carry very, very significant costs, especially at the scale that we're talking about. And they were not able to be tolerated by this particular site. A membrane system by itself was a fairly big challenge. We had some other folks pitch to us some technologies involving CO2 and other membrane facilitated precipitation. So what we landed on was something simple. We had to recognize the regulators. We had to recognize the limit, 300 milligrams per liter. We had to recognize the ammonia and the nitrate as well. And if we looked at each of those things separately, we were going to have 3 different technologies. And 3 different technologies, all operating is very difficult, very sophisticated, requires a lot of operating capability. Whereas when we looked at membranes ticked the boxes. So it became an economizer step. But we still have that waste to deal with. So we understand fully what the geochemical restrictions and limitations are. So we actually had to cycle this thing up even further. So in our membrane process, we have a cycle up process as well. And I can't tell you what it is, but you could probably guess relatively easily what it is. And then we went with the precipitation process. And that precipitation process, relatively simple, lime precipitation, to bring that geochemical, to maximize geochemical solubility, be able to really attack that. So we got membrane process, precipitation process. And I'll talk on my next case study about why it's not the other way around. Because a lot of folks will tell you precipitation process is first. And I disagree vehemently with that. So that's where we're at. But the innovation is membranes aren't particularly innovative. The cycling up process, there's a couple of elements there that are fairly innovative. And then the final part is that precipitation process, nothing particularly innovative about that, but the way that we operate it is very innovative. So I can't tell you what we do, but I can tell you we don't have a thickener. So we don't have a clarifier thickener. We employ another technology there that saved us massive amounts in footprint, space, and in operability and cost. It was pretty cool. Now, it wasn't easy to get across the line because it had never been done before. And Newmont being fairly averse to new things, I remember the day quite well where they told me that they thought I was mad. But we built this thing at one of a smaller scale. We've operated for 5 years now, very successfully. I have a photo in a couple of minutes of what we're doing, how we're doing, so you can see a little bit. But it's a very cool process. Now, it isn't patentable by any stretch, but we operate it as a trade secret, which is why we haven't told anybody about it. And you haven't seen us at industry conferences telling people what we do. You can see on the right-hand side there, that's a little friend we made out of the first gypsum that we precipitated. So a little mascot. So again, that process to bring that innovation through was needs-based, understanding where were we at in that cost tolerance sort of schedule, regulatory elements, simplifying things, making sure that we weren't trying to put in a square peg in a round hole, recognizing the cost pressures, recognizing what the innovations look like. We did have some other struggles with the site, with the regulators in country as well, that were trying to mandate specific technologies. But we had a great deal of capability. And going back to that photograph of where I work, that facility, that process, we had done a lot of this work, and we're able to back the technology to the regulator, and they allowed us to advance. We permitted, and now we're constructing a number of them. So what we've got here is, this is the plant that we constructed. So you can see the lime silo there, you can see the UFs, you can see the membranes. That's what we constructed. And now we know that this is not something we want to tinker with PPMs around. We know we can deploy this at other locations that have very similar restrictions, regulations, and feed water quality. So we're actually constructing 2 more of these. We already have the engineering design. We already know what the capital cost is. We already know what the operating cost is. We're able to rapidly replicate these without studies, without engineering design, and just throw it in. And that's very much where the mining industry wants to be. But we don't seem to really enable that process to get there. So this took me and my team over 12 years to get to this point where we can now rapidly replicate these things. But that's the goal, right? So we utilize that investment system to be able to look at all the options. We use the tools that we had, the predictive elements that we had. We leveraged the regulators and our technical strategies. We performed what I would call targeted R&D. It was targeted at the need, but utilized our systems. We executed that investment, and now we can rapidly replicate that. So that's the story of that investment, right? That technology. It's nothing super flash, super fancy, but that's the process that we got it to the point where now we rely on it, and there are folks coming into the business that don't know an industry without, or don't know our sites without these things. So this is the pond. This is the gypsum that we produce on the backside of our precipitation reactors. It's fantastic, and the water quality that we have here. There's frogs and fish living in this pond, unfortunately, but it's a great goal. A great outcome from the process, and we can point to it and say, well, this is what we produce. and we're solving that issue with cycling up RO brine and things like that that are typically considered to be a bit risky. So we've got a lot of credibility out of it too. And now when we engage with the regulators, they know that what we're capable of and how we can do it. So directly pivoting on that. So we had a very similar situation at a site in the same area, but we developed the right tools. We knew what we were facing. We collected the right data, made the right predictive elements, cross-functionally worked with everybody. We tracked our performance after we executed the fix, which was a new strategy that takes those larger fixed plants and pivots to mobile plants. Now, we could never have put mobile plants in if we didn't build that fixed plant in the beginning. So now that's that scalability. Now we can scale these things as needed without having to spend huge dollars and reacting to the cost pressures that we have in the mining business because it's not core business. So that's what we did. We could see that we had this very, very high rainfall year. We were tracking very, very high. We implemented a mobile RO system, and we didn't have an emergency. We didn't contaminate any water. We didn't have anything over top. We didn't have to load our TSF. We executed exactly as designed, and we were able to go back to the regulators and say, hey, thanks for your support and permitting that on the fast track. We solved it. Now we're good. I'm hoping that the message coming across here is just how the planning aspects and how that technical engagement in those planning processes and investment systems, just how important it is to get that right. So that's really where my point is, I guess. So moving on, South America, this case study number 2, completely different type of innovation here. This is something that it's a large scale asset, one of the bigger gold mines that the world has, and a lot of challenges around the geochemistry. Again, going back to those focal points from the beginning, what are we doing here? Well, we're trying to understand that geochemistry and that water quality. The scale of it means that the quantities are also very, very high. So here's what we're sitting in with respect to the sort of potential water quality that we have, acid rock drainage and saline drainage. The fact is we've got to treat those solutions. So again, brownfields entry point. The site had sort of operated without fully understanding what the potential was for some of the water quality elements and how they might evolve and where they might land. So we were, same as the previous site, we were observing these things, watching them happen and just hoping that they would either stop or go away, or this was just an anomaly and it wouldn't be continued into the future. At the same time, we had a lot of regulatory change. So real compression of what we were observing and measuring and the regulations that we had. Again, cost pressures are fairly ubiquitous, so we've got to make sure that we're not, the plants that we have here aren't going to miraculously make more money. So we've got to make sure that we can limit the costs and target the right technology here and be as adaptable to the future conditions and state as we can. So obviously there's a lot of community stakeholder engagement and interest in this location. And again, large scale, very, very large cost. And we started to look at R&D elements on that parallel track. Now, we didn't recognize these things, so nobody was going to fund R&D from the site. That wasn't going to happen. So we had to fund that R&D based on a long-term look and put some dollars into it and invest in it. Now, the photos you see on the right there, we're seeing lots of scale, lots of challenges in the treating of that water quality. We're seeing the challenges at the membranes and a lot of challenges there. So here's a few photos. Some of the sludges that have been produced as a result of this acid water certainly has an impact on our ability to manage water around the site. We've got to make sure that we're fixing this stuff. So there's a lot of sludge that's being developed. You can see lovely pictures there. You can see what the membranes are doing. You can see what happens when we can't get all the water out because we're constrained by the chemistry. Right now, we can seasonally manage this, but these are the impacts. Anybody who knows anything about ARD can probably predict the water quality that you can see in those photos there. So next phase, development. We enter the investment system. We largely entered the investment system, not because of the problems that we were seeing, but because new projects required that those systems, those water management and water treatment systems, and we knew that adding additional resource to this site would require changes to those systems because the systems can't tolerate that expansion. So we knew what it needed to be, but we didn't realize at the time just how much we had expanded beyond the capabilities of the existing system and how close we were to not being able to manage water effectively. Again, lots and lots of consultants involved. The consultant go around, everybody's doing all this work, but no one's really got a cohesive strategy here. So that was a bit of a challenge to pull that back and get that on the right track here. And then looking at operational elements. So we were seeing these sludges turning up. We were seeing inability to meet our water treatment KPIs. So we were band-aiding a lot of that, and that some of that made things a lot worse. And then we weren't engaging with what those fixes were and what the changes meant. So it was a challenge. And then off-ramps, again, taking these off-ramps, moving water around, can't possibly be that bad. Let's rework these assumptions, but reality will always hit. So where are you at? Now, if we had waited until reality hit and not been engaging in that investment and that innovation system, then we would have been pretty well hosed. So what you can see there on the right-hand side at the bottom, that's the prediction changes in terms of mass loading to our system. So not, showed that we didn't really have a great understanding of what the predictive elements were. Those are reality numbers. So we had to then go back and then make the necessary adjustments to be able to make the investment justification. So this is where I just wanted to add this. It's a bit of a global look around some of the other sites and that are equivalent or similar in some regards. We did a quick check on what the water treatment technologies are in some of these equivalent sites and what they're doing. You can see a mix of RO, seawater RO. You can see ARD treatment, lots of ARD treatment and RO. So RO is definitely where we're heading. Membranes are a really key element here. And I think that the ability to treat that wide range of water quality and that evolution of water quality without having to argue down to the ppm, what's my technology going to do and what's the right technology, hitting it with a broad brush and hitting it early and knowing that we can rely on it is a really critical piece. So what we're looking at here, and this came down to an argument around whether or not we should have treatment first followed by membranes or membranes followed by treatment of the concentrate. Now, this is where the innovation comes in. So we had looked at this in a number of places, and I'd been on the ground down there trying to run an HDS plant, so a high density sludge plant followed by a membrane. I wrecked that plant in, 2 days. We just could not get it to work. And we went through a lot of consultants who all told us, yeah, it'll work. It doesn't work. We know it doesn't work. And I'll caveat that by saying that the chemistry that we're talking about is too unstable after an HDS process. You'd have to stabilize it, which means you would need space, you would need ponding. And we know that we don't have that. And I would argue even then that's probably not suitable to then go to a membrane. So we looked at membrane first, and pretty much everything, and there's probably a number of folks on the call here today who would say you'll never be able to do that. What we have in terms of the predictive capability available to us would tell you that it won't work. So we had to develop a set of parameters to operate within that and see if it would work. And there's only one way to do that, and that's to try it. So we did. And so we got down there and we ran it. We've since done another pilot. So I sort of muscled in on another project and was able to put a water treatment plant on the back end of that other project and have them pay for that. That R&D, it just keeps it moving. That connectivity into investment keeps moving because you can't come in cold with an innovation. So we had to develop that. And then eventually we knew that we had a really big problem here in terms of chemical compatibility with the treatment technology that we have. And we're right at the edge of what that technology that we already have employed can do. So we had to make a change. So essentially we've referred to it as acid RO, but there's a number of ways you skin that cat. You could call it something else and call it just direct feed RO, something along those lines. And we had to figure out how to get that solution compatible in the first place with the membrane. How do we take advantage of that, economize a step, and then how do we scale down our RO concentrates treatment systems? And then can we recombine that solution and send it out the door? Now, ZLD is not what we're trying to do here, but ultimately it's improving the recovery and discharge efficiency from a number like 70 or even lower in a lot of cases, 65 to somewhere in that 80 to 90. And that the economics and the value of doing that is very easily calculated. And if you can make that work, the capital costs come way down, your operating costs largely stay fairly similar, which for a lower capital cost is pretty good, but it does give you the ability to get more water out the door for the same cost. So on a dollars per cubic meter treated or dollars per cubic meter discharged basis, there's a lot of value there. So that's what we've landed on. Now, that technology, I can't give you the details, obviously, because it's horrendously proprietary and it's worth an awful lot to us. And we've taken that through the system. We're still piloting now, but we are engineering the plants, and we're taking a $600 million investment, and it's on the back of that innovation process and that ability for us and the team here to keep it moving, to work with the investment system, provide that opportunity at the right time to be able to get it considered and to get it executed. So it's a terrifying risk, but we believe we've got that sorted, and that direct feed RO benefit is now really starting to realize itself through that investment process. So that's where we're at. That's my presentation, everybody. So I really appreciate you guys attending today. I'm wrapping up with a slide here that's a little bit focused on that business process side of things. So are you aligned with a focus point? Preferably more than one. What is your entry point to this investment? Where are you at? Where is the company at? What are the off-ramps that they might take? And how can you work with them to make sure that you've got something that is expected and able to be tolerated in terms of the cost profile? Are you flexible, scalable, and adaptable? How does that work? Are you market ready? Do you require development? If you require development, probably going into a site isn't the right place to go. Coming through the innovation pipeline is probably a better location. And then what's the level of specificity that you have with regards to those focal points and the tolerance to the costs? So where are you at? So on the right-hand side there, you'll see there's a photo of me and a lab manager down in Peru operating this acid RO plant. And so I'll leave you with that. And I'm happy to take any questions. And again, appreciate your time. And thanks to NAWI for putting this together.
Great stuff, Jacob. Really, the operational experience, especially just talking about, you were just down in Peru doing this, right? Getting this thing running.
Yep, that's right.
Yeah, 600 million is a big investment.
For us in water treatment, it's the biggest that we've done by a considerable margin, yes.
And you think that this could potentially have a larger impact across, which obviously why you put some protection in around it.
We believe so, definitely. I think that I look at things on those time horizons, and I would say pushing out to that sort of 10 to 15 year time horizon, potentially very valuable in that space when we have less of the oxide deposits, more sulfide deposits. We're able to manage that chemistry a lot better, and we have a technology that we can plug straight in. And if we're at the point where we've done it, proved it, and can deploy rapidly, it might be something that's worth an awful lot to us.
Okay, I guess one thing, and we have quite a bit of questions, and I always want to encourage people to ask questions. Peter had a lot of thoughts on this, and I want to make sure that I give him time in just a sec to share his thoughts with you too. You know, when you have innovation, right, and you have some of these technologies that are new, you guys are kind of a group that handles some of that. I mean, how do you even get to know people? I know there's consultants, there's this, there's that, previous experience, relationships. You know, if someone's got an idea, what's the right way to approach a company like Newmont?
It's a really great question, because you're absolutely right. There's a lot of there's a lot of relational type ins, right? So you got to know somebody somewhere who you can come in. There's often consultants that are preferred because they've been good providers for organizations. Newmont tries to come back from that a little bit. We like to be agnostic, and we like to consider options and opportunities. That does take time, and it takes a little bit of diligence. So in our system, I believe actually anybody can go to the Newmont website, go to the innovation portal, and click submit an idea. And that's something that would go straight to our innovation folks. And they are, I mean, it's a whole department. It's a department that looks at these things, directs it to where it needs to go. If it's water, it would come to me and my team. We would take a look at it, and then we would say whether or not it's worthwhile engaging, whether it's, again, aligned with those focal points that we have. But pretty much, I mean, we're all very busy. We do like to engage as much as we can if there is something. So the last few years has been a little bit tough with getting out to conferences and getting to those places. But there's a number of ways. You can go through the conference route. You can go through the business development route through contacts and organizations where you think you might have something that targets it, targets a need or targets an opportunity. There's a number of ways. In our company, coming to my function is the right way to go. A lot of folks, they see that as disabling because they want to get out, and their development pipeline is, I want to get onto a site and I want to try this out and I want to see it go. Now, Newmont doesn't necessarily want to do that. We want to spend the right money the right way. So coming through my function and making that assessment, but if it gets past that assessment for us and then we start to look at it, we begin this development in earnest, and we'll start to say, hey, let's do something in our lab. We have our facility, please come along. And we've done this a number of times, more than I can count, certainly. And I don't have shoes on, so I can count to 20 right now. So there's a lot of opportunity there that's to bring this stuff forward. We are absolutely, and again, another way is if you have contacts at mine sites that they might say, hey, we've got a need but not a budget. There's an internal submit an idea, and you just say, hey, did you know that we can do that? So it may seem a little bit diffuse, and it probably is, but obviously I'm sort of that point where you can bring it to me, and we'll look at it. And there's ways to do that through my LinkedIn profile, through my email address is a fairly easy one to figure out, and I'm always happy to engage that way. So we love to engage those things. We can't promise development pipelines, but we do promise that we have a very, very targeted and diligent assessment process.
That's great. One thing that came to mind where you were talking about that was, NAWI is in the process of going through our piloting proposals that came in, and some of these might be an interesting opportunity for companies like Newmont to look at technologies at a larger scale. And so we'll have to see how this all goes once the announcements get made. But that FO is out there. Well, was out there. We're reading the proposals, and we'll see where it all comes together in the end. Because scaling, and not the kind that you get on the membrane surface, is really important. We hear that all the time in the ICC. So, all right, Peter, I want to make sure that you have a chance to share your thoughts here because you had a lot of good points. So take it away.
Thank you. Well, Jay, I'll ask the first question, which is my last question, which is Newmont hiring? It sounds like a really exciting place to work. And where else do you get to build, large scale treatment facilities? So what is, candidly, you've got 60 or so largely early career people on the call. What's your advice for people interested in a career?
Newmont is hiring right now, and it is a difficult environment to hire as well. But so let me tell you that. So what I've presented to you today is that we've got that innovation side, we've got that investment system. What we also have is something that I've been working towards for about 12 years since I came to the States, which is a whole new function. People do not come out of school and do what we do, right? So they go into either technology development or environmental management or some perhaps chemical engineering or something along those lines. Right now, we're hiring 5 regional people to manage the process of delivering this type of thing, both in terms of management and in treatment in each of our regions, one in Africa, one in Australia, South America, North America, and Canada. So the jobs are currently available on Newmont's site, and you can take a look. We're also about to hire on every one of these sites to back up the processes that we're talking about today. We are hiring what we call a water lead on every one of our 12 operations. And those, right now, I believe only 2 or 3 are currently advertised, but there will be another sort of 9 or 10 coming up between now and the end of this year. So we're not only backing us, we're really backing ourselves on this, because we see what those costs are. We're dealing with those uncertainties through a maturity process. We're providing the resources in. So in my team, I have one role coming up next year, which is to manage the tools element, the predictions, the models. We have a strategic partnership that we're developing. We're hitting this very, very hard, and it's taken me and my team 10 years to get to the point where enough time in the boardroom, enough time in front of the executives where they're sick to death of it, and they're like, what's a better way? How do we do this better? So that is exactly what we are doing right now. I think it's an exciting time. I think it provides a community of folks that are operating in a similar space, all with common goals, all with a common objective here that does not exist in other parts of the industry. You might be a consultant and do small parts of this, but this is a chance to own it, develop it, and move forward. So yeah, love to see those applications coming in.
Matt, can I ask another of my questions?
Oh, go ahead, Peter. Yeah.
So I actually want to kind of zoom out to the other end of the spectrum, which is Jacob, you and your all of mining right now is dealing typically with solid stuff in the ground that you dig out and process and extract. And yet one of the things we're focusing on at NAWI is precision separations out of the liquid phase. And in some cases, people are mining brines right now, for example, lithium in the Salton Sea. Knowing what you know about water treatment, knowing what you know about the mining industry, is there a genuine potential in your mind that mining companies will be mining brines in the future? And if so, what would you predict to be the early deposits or resources that might be directly extracted from water?
That's a really great question. The answer is absolutely right. I think that we're on the edge right now of what those the specificity around membrane and separation, and I think that it's twofold. Where I see things going, at least as an opportunity, would be looking at it as an economizer and then applying the specific technology to a smaller scale, because a lot of the costs that we're dealing with are the sheer scale of what we do. It's enormous. We're moving massive amounts of materials. Yeah. So I think in the precious metal industry, there have been a number of forays into solution mining, where you inject and you recover and you process and then you recirculate. I believe that there are some constraints to that. They have to have some pretty specific hydrogeology components to that. That's not to say that they're not able to be engineered in the longer term. But I think that metallurgically speaking, and this is the brave new frontier as far as I'm concerned, is what I'm dealing with and what I'm talking about is waste management at the end of the day. Wastewater, waste interactions of waste solids with water that becomes wastewater.
Right.
So there's a lot of stuff there, but we have started to look a little bit over the course of time in, can we apply the same approach to metallurgical operations? Can you economize there? Can you make them smaller? If you could separate copper cyanide from gold cyanide, what an amazing thing that would do for us. We could then recover that copper, we could split the cyanide, reuse the cyanide, and then you've got this massive economic benefit there. Just in terms of processing material through, we use large carbon vessels to be able to absorb the target, gold cyanide species. If we were able to make that far higher concentration, far smaller volume, the economics of those systems is very obvious. Now, the challenge there is that you've got, like you said, you've got a solid liquid system. It's a slurry system.
Yeah.
Is there a way that we could use, and I love ceramic membranes because you can set off nuclear bombs, right? So if you could do a ceramic separation of those solids, take the solution through, and now process that solution via a membrane, bring the concentrations way up, volumes way down, recirculate that back to your process at the beginning. What an amazing thing to be able to do. Now, you've got me excited because I'm an ex-metallurgist, recovering metallurgist. So, I mean, that metallurgy side of things, I think that there's a lot of opportunity there. And then that has the benefit of reducing the overall waste that you would have to process later.
That's
anyway.
right.
You could combine these two things and do something fantastic. Now, there's a lot of headway there, and I don't think that's a 5-year thing. For me, the time horizon there is a little bit longer, but I don't think we've fully realized what ceramics might be able to do for us in terms of that solid liquid phase. And then it opens up the doors for some more membrane applications. And I've also seen some fantastic things around like specific impregnated membranes that can do some great things that you can elute, like an ion exchange resin and things like that could be enormously valuable as well. So great question.
Great, thanks so much.
Hey, Jacob, one thing I was thinking about, I just went over to the site because I was like, I wonder where these jobs are. If somebody could just send the links, because we'll post them into the Alliance community, so you can maybe get some qualified candidates from the NAWI team. And Jen and I can work with you on that offline. But I think, with opportunities there, we always want to make sure that the folks that are interested get a chance to apply. So.
Absolutely, and you can. So I posted the links on my LinkedIn page as well. With a post. So they're there. I'll just check that some of them may have closed in the last couple of days, but I can reopen them. And anybody who wants to apply, I'll reopen them for another week. And because we're not in a super big hurry, we're looking for fantastic candidates. So.
Okay, that's great. Yeah, we'll talk offline about that and make sure we have the stuff.
Absolutely.
Let's see. I'm trying to see if there's other questions. Anybody else? I mean, Peter and I could probably talk to Jacob back and forth.
I could talk his ear off until the lights dim. Yeah.
I know.
Well, Jay, can I ask a specific question? You in one of your slides, you just snuck past what I thought was a horrific, exciting image of a membrane pressure vessel and some like cement and chisel marks on it. Was I seeing that correctly?
Yeah, you were.
Oh my God.
So for those of us who have had the unfortunate pleasure of dealing with this before, so that membrane there, so we what you can see is, and everybody knows this as well, right? You try and rip those membranes out of there that are glued to the inside. You start streaking and damaging the inside of those vessels, and you can have all kinds of things go wrong. So there's stainless vessels in this particular location, but that membrane there weighs 36 kilograms, goes in at about 8, and it's all gypsum. And we tried really hard to get that one out of there, and we ended up having to put I think it was a 40-ton come-along winch to get it out. So yeah, that was a bad day.
Well, so it's a bad day, but the one thing that NAWI is investing in is better geochemical models, so like ways of doing a better job of predicting. So not to like completely like ruin your afternoon, but with respect to this story, was this an example of just not running a model and in hindsight, you probably should have run that and seen just how far into the gypsum gypsum curve you were? Or is this an example of an accident that happens because the model said you're all clear and you open the vessel and it's full of gunk?
So let me I'll give you a real quick. And I don't mean to go too deep into technical. I'll keep it as light as I can. But so this system here, Yanacocha, and I just gave away the site, but it was pretty.
We saw from your map. We know.
Yeah, it is we've been operating membranes for about 25 years. So we phase membranes in. So what happens? Obviously, there's a concentrate. That concentrate goes around in a circle. It comes back to some asymptote of geochemistry that is not a natural solution.
Right.
The requirements on the gold mining side of things is you've got to have an alkaline solution to keep cyanide as an ion and not a gas. So we use lime. Now we've got calcium. So when you've got calcium and you've got sulfate oxidation or sulfide oxidation, it produces sulfate. Hey, here's your geochemistry lesson in gypsum. So what you've got is a solution that is supersaturated with respect to gypsum. Now it stabilizes, and like I said, it's not a natural solution. So you can't take the models of solubility and apply them. we can do it empirically. We know that there's the ionic strength here, and the common ion effect generates a far higher solubility index of gypsum in this particular solution. Now, we don't know what that is necessarily. We don't know all the mechanisms that are keeping it that way, but we're quite happy about it. So what happens is that there's a limitation in how much you can cycle the concentration up by. So normally sort of 4 times or something like that. You start to get to 8 to 10,000 ppm of sort of sulfate, and maybe 2 to 3,000 ppm of calcium, and it stays in solution. Now this is a 3-stage RO, and this is stage 3, and we had a couple of things happen. So we're right on the ragged edge, right? We're right on the ragged edge of this, and I would say that stage 3 probably doesn't work, probably doesn't do very much anyway. But in this particular case, we had 2 things that occurred. The first one is that we do side slope leaching, and when we recirculate our solution from our RO concentrate, we like to put it 2 towns over, right? Let's get it way away from here. Let's get it through the rocks. Let's let it stabilize from a supersaturated condition to something that's a lot less supersaturated. And that gives us a more stable solution feeding back into the membranes, right? In this case, they did some side slope leaching that was like literally next door to the plant. The solution didn't have the same time it came through, and it ended up starting to get a bit funky, and we saw some of this happening. And then just to add insult to injury, we had somebody turn off an anti-scaling pump.
Nice. Yeah.
So,
oh well.
Hey, that happened, and then
what's this knob do? Right.
Yeah, less than 6 hours, the whole plant was down, and we had to go and fix it.
Yeah, Jacob, when you were looking at this, so the ones around this particular one that's obviously broken in half, were they similar in the way that they were looking, but just easier to extract?
Yeah, I would. If I do have another photograph to show you a vast bunded area full of membranes,
dead membrane modules.
So luckily we have tailings facilities, so we can dispose of these things in. But yes, they were all exactly similar. This one we could not get out of there. It was just couldn't get it out. So that hence the photo. But you can see the one above it as well. Yeah. That's one that isn't broken. And you can see it is pretty much just solid.
Solid, yeah.
And this is all from the 3rd stage, just this particular, all these sets of pressure vessels. It's fascinating.
On an innovation standpoint, so this happened to me in New Zealand. We actually, I mean, from an innovation needs must perspective, we developed a reagent that I took the membranes that were in the 28 to 30 kilogram range, and I threw them away. But anything that was sub 25 kilograms, I could recover to 8 kilograms. I could get the gypsum off it.
Wow.
Yeah, and it's another one of those trade secrets that we operate. That we know that if we get in real trouble here, we can do it. It's relatively simple. But it's something that we don't talk about either. But we can get most of it off.
Yeah, Jacob. Another comment I made in the chat was sort of back to you. You were talking about how there are kind of three zones where new technology can come into play. Greenfield, where you've got plenty of time to think and blah, blah, blah. Then you have sort of, brownfield, but then you have or other words that somebody might say. And the comment I made, I'd just like to get your reaction is, yeah, from your standpoint, greenfield is the easiest because you have plenty of time, et cetera. But one of the challenges for startups is they don't have years to wait around for the project to come online to sell. It's more often the case that a water treatment technology is they're going to be able to make a sale when somebody's fingers are slammed in the truck door. Yes. So is that just an inherent dilemma? Do you have any thoughts about how you cultivate innovation when these sprouts need to be watered and you're not going to be able to harvest for a couple of years?
It's the conundrum of all of the conundrums, right, that we have, because from my perspective, it's easy to take a technology that if you've got a problem that exists and you've got a solution to that problem, you put those 2 things together.
Your house is on fire. I have a hose of water. Sure, exactly. Come on by. Yeah, that's easy.
Those pieces are really important, but I think of it in terms of positioning, right?
Yeah.
So you've got to position yourself that you do have a solution that you've developed to some point that you're, in some respects waiting for the problem. Now, mining is a tough one because we like to, and even, I mean, I've been in projects in the face of a simpler, cheaper, faster, better alternative. I've had the organization say, "No, I'll go with the one that I know."
Yeah.
And it's easier that way, and that's what I want to do. So that's why looking at this in terms of what's the entry risk. So if we have a solution and if we have a problem and you have a solution, hey, let's put those two things together. You want to position yourselves to be able to be in that space at that time. That's a tough one, a tough thing to do necessarily. But that's why engaging with the company, like a company like Newmont, and saying, hey, just look at what we've got. And we keep that on our books. And I can go back and say, what's the sulfate treatment technologies that we've reviewed? And what's the glossy brochures that we have? And what's the contact information that we have? We keep all of that in a file. And that file is if I get hit by the beer truck, that file is available for the next person. So it's not like the old way of just, I know something and I know some person somewhere and I can direct that. So we're trying to be more agnostic to those relationships and more targeted on what the real value is. But another piece to this is being in that loop and saying, well, let's get a review. Let's get something in place, either through innovation or through those contacts, finding that way to get in front of these companies that may or may not have it. The real problem becomes, I think, that when you do have this terrible sort of outcome where you've got to do something right away, just look at the reactionary management processes that larger and even smaller companies will do. They will just go with what they know. So they'll go out to some company and say, well, we've done this before, when that is garbage. They've never done it before. And they want that sale. And that's that. There's a lot of value in that name recognition and that company recognition. So you've got to compete with that in some way, shape, or form. And that's why partnering with a company like Newmont, where we have those processes in place to say, hey, let's consider this. It doesn't necessarily water you to the point where you've grown to that critical mass, but it might help you to get there. And it might be that maybe we do a test in the lab, and that gives you a little bit more sort of pertinence there. I can give you a really interesting example of we have these innovation challenges, and one of them is the Clean Tech Innovation Challenges here in Colorado. We went through a process where a university incubator had developed a mushroom technology that they thought would be able to be competitive with coconut husk, which is what we use as an adsorbent. So we looked into that process. We did all the testing. We said, look, it's just not competent enough material. They went on to generate, they completely pivoted and said, well, that's not what, we can't do that then. They pivoted, and now they make the real meat. It's a real meat product.
Oh, I mean, darn. Isn't that great? And so, kind of the lesson learned is, like, you're doing everybody a favor by getting to the bottom of it. Like, is this viable or not? Don't fool yourself. Don't waste time. So I think that sometimes there can be a case that innovators sit there and say, well, I can't possibly talk to Jacob because, like, then he'll know my secret. But the issue is, you've got to get out there and just walk through the scenario with people, begin to kind of explore the true understanding of the application space and whether this has got viability. And also, a lot of times I'll say, in the research side, Jacob, we often do not have a good understanding of what the current frontier of treatment technology is, right? So we go to literature, but what you just got bid from, a strong engineering firm like Jacobs, like, so Jacobs came to you with something new. Nobody knows about it. We in the research community don't know about it, but you know about it because you're the ultimate customer. So that sort of insight coming back to us to say, hey, of all the things I've seen, this is the area where I think you need to focus is really helpful. And of course, I'll wrap up and say, Jacob, you've been a great partner for NAWI, and Newmont's been a great partner because you've been engaged in giving us lots of advice along the way about what the priorities are.
Yep, for sure.
A couple more.
I do see one question in here that came in.
Yeah, what's Rockreed? Why don't you get that guy to unmute?
We can't. Just see if we can. Okay. Can you add, Dennis, if you could add a short description of Rockreed? That's not something that we're familiar with. Have you heard of that before, Jacob?
I see Jacob's wall. I know what rock music is, but I don't know what rock read is. I know who Lou Reed is, but I don't know. I don't know what rock
Vinyl.
read is.
It's all about the vinyl.
Sure is.
So all right, I'm trying to see here. If Dennis
find
Dennis
Dennis.
can follow. Dennis can
Dennis,
follow
you
up.
can fight
too.
your way to the microphone, buddy.
Yeah.
Yeah.
So
Jacob,
okay.
as final question, what was
Yep.
your favorite place to live in your career so far?
Ooh, great question. I lived in a number of places. I spent a lot of time in Peru. I spent some time in South Korea, Australia, New Zealand, the US, obviously here. I've spent considerable amounts of time in Ghana and a lot of other places, but I'll say that I love New Zealand. New Zealand's a great place to be, and there's a lot of cultural stuff that just is what I am, and that lifestyle of fishing and surfing and working was pretty fun. But I would say that I really enjoyed my time in Peru. Peru has been a fantastic place. The people are fantastic. The culture and the history is fantastic, and I've really enjoyed my time in Peru.
Wonderful. Thank you for sharing that with us. Matt, why don't you take us out?
Yeah, as I say, that's one thing. That's a great question, Peter, because in mining, you go everywhere. Actually,
You go everywhere. That's right. That's a joy of geology. Yeah.
I was looking through those jobs, and regardless of what I was, one of those days, and it was a plant manager in Suriname, right? And it said Suriname has 2 wet seasons and 1 dry season, and all this like back and forth. It's just interesting. You don't get that every day when you look at options for doing stuff. So Jacob, just wanted to go ahead.
All right, Suriname. Put it on the list.
It's a great place. Very interesting history. Very, very different. The only place in the world where there's a mosque and a Catholic church. A mosque and a Jewish temple.
Synagogue.
Right next to each other. And it's fabulous. The history is amazing.
That's cool. Yeah, that it's a different world for that kind of stuff. So Jake, with that, let's kind of wrap up here. I know you put a lot of work into this, and it obviously came through in the presentation. People, really like getting the 130 people to sign up and see this is because mining is interesting. I think that a lot of us who work in the water community, there's a lot to learn from this. You deal with some aggressive conditions and things that are important for us to consider. And like Peter said, your engagement with NAWI and the perspective you bring is really appreciated on the ICC and beyond. So thank you again very much. And we'll get you in another 6 months. We'll have another topic that we can talk about. But everybody, thanks a lot. Please continue to check the NAWI community site at alliance.nawihub.org for future webinars that are coming up. And as Jen said in here, actually to connect with these people who we're able to do. They're all connected in there, and we can keep going it that way. Jen and I will try to find the open jobs, like Jacob said, and post them to our jobs available site within the NAWI community site. And everybody enjoy the rest of your day and have a great week. Thanks again, Jacob.